Okay, so the last part of question number 3, we're going to apply Newton's method, remembering that if xo is 0 and I define f of x, then the new value of x will be the last value of x minus f of x over f dash of x. So I'm going to set up this situation. So I'm going to define this as f of x. I'm going to write 0 xe, and I'm going to write x minus fraction, and in the numerator I will have f of x. In the denominator I'll have the derivative of f of x. But because I wish to recalculate this every time, I'm then going to say math 3 given x equals the last answer. Now make sure this is in your bound book if it's not already. So my first iteration, I'm going to get negative 1.442603. In the next iteration, negative 0.897. And in the third one, negative 0.774. Okay. So in G's case, explain why this should not be used as the initial estimate. Well, it's either that the derivative equals 0 or that we have an oscillating situation too far away, or that we have some sort of hybrid function, which we don't have in this case. Okay, so let's see what these values are. So log base e of 2 log base e of 2 times 2 to the x minus 2x equals 0. If I solve that and solve for x, I get these two answers. X equals 0.4850896, or x equals 3.21 4325. Now, these two numbers are the endpoints of our strictly decreasing, which means that the graph has a maximum, what does the graph have? F of x. So we have turning points at these cases. So at these x values, f dash of x equals 0. Therefore, Newton's method will terminate because of a division by 0. And in the last question, we're looking for f of x having a local maximum on the x-axis. Therefore, f of x equals 0 and f dash of x equals 0, and I wish to solve for n and for x. Now, if 0 equals n to the x minus x to the n, then x to the n equals n to the x, which only can happen when n equals x. They have to be the same values, like 2 to the 3 equals 3 to the 2 won't work, but 2 to the 2 equals 2 to the 2, or 3 to the 3 equals 3 to the 3. So we know these situations happen. Let's try and see whether I get something out of this. So I'm now going to define n to the power of x minus x to the power of n. Press the x here, make sure it's all okay. It is. Define that. Now I've got my f of x. So I'm going to copy that and I'll set up simultaneous equations. No, simultaneous equations. Do that again. Simultaneous equations, thank you. Paste equals 0 and paste equals 0, but I want the derivative to equal 0. They're in the wrong spot. And I wish to solve for n and x. But that didn't really solve anything. So what I might like to do here is I'm going to put in given x equals n, no, n equals x. So I get rid of the n and I keep x's. If I was to solve that, 2.718, which is E. So n equals E has been the answer.